Section 4.5 is about derivative of exponential and logarithmic functions. Let's start with the derivative of logarithmic functions. We know that logarithmic function is a function that represents the power of some exponential form. For example, 2 to the power 3 is equal to 8. If we want to represent 3, the power, using different or by a different way, we can use logarithm. So it's logarithm base 2 of 8. And the logarithmic function, we studied this before. What do we mean by logarithmic function and how the graph looks like and many properties of logarithms. In this section, we'll focus on how to find derivative of such functions. Just let me remind you of some notation. We use log base a of some function in general to denote logarithmic function. Now, if a, the base is e is a number, it's about 2.718, etc. So then we don't need to write log base e, but we write natural log, ln, natural log of f of x instead. So natural log means log base e. And here we need to distinguish between those two notations. We have log base b and natural log, because derivative will be different slightly between derivative of log base b and natural log. And we know that if we don't write anything here, that means it's log base 10. That's the ordinary log. Okay. Here, let's start with the first one, the derivative of natural log. Derivative of natural log of some function is derivative of the inner function. The inner function here is f of x over the inner function. So this is derivative of natural log. We have natural log of this function. So we find the derivative of this function, this inner function, and we divide by that function. And if we have log base b for any b different from e, then we apply this. We find derivative of the inner function and divide by the inner function, but we multiply the denominator by natural log of the base. And here we have same thing for derivative of natural log. We can multiply by natural log of the base. What is the base of natural log? It's e. But we know that natural log of e is log base e of e, and one of the properties of logarithm says logarithm base a of a is equal to 1. So since all those are the same, that means this is equal to 1. So here we can put 1, but since that will not change the result, we just find the derivative of the inner function and divide by the inner function. Okay, now let's use these formulas for derivative to find derivative of logarithmic functions. So we start with logarithmic functions. What is derivative of natural log? So the derivative is, what is the inner function? It's x. Derivative of inner function is 1 over the inner function x. For the second one, g prime of x. What is the derivative of the inner function? It's 6x minus 0, which is just 6x, over the inner function, it's 3x squared minus 2. We don't have natural log here. We just find derivative of the inner function divided by the inner function. Here, what is derivative of h? Here, this is log, so we use this formula here. So derivative of the inner function is x. Derivative of x is 1 over the inner function x times natural log of the base. The base is 2. Here, what is derivative of f? Derivative of the inner function is 3x squared plus 1 over the inner function x cubed plus x times natural log of the base. The base is 3. Here, for this problem, it's better to write the square root function as x plus 1 raised to the power 1/2. And then we know that one of the properties of logs is that we can bring the power here. It becomes 1/2 natural log of x plus 1. This is the function f. Now we find the derivative. What is derivative of the function f? 1/2, it's constant, times derivative of natural log. What is derivative of natural log of x plus 1? Derivative of the inner function is 1, because derivative of x is 1, derivative of 1 is 0, over the inner function, x plus 1. Now what about derivative of exponential functions? For exponential function, if we have e raised to the f of x, then we find derivative of the power f of x gives f prime of x, and then we multiply by the exponential function, same exponential function. If e, in general, this is how we write the exponential functions, a to the power x. Sometimes a is e, it's 2.718, etc. So we write it as e to the x. So this is exponential function. Now, if we have if it's e to some power, then the derivative of the power or derivative of the function f of x is f prime times same exponential function. Now, in general, here this is a to the x or b to the x, any constant to the power x. So if we consider it as b to the x, what is the derivative of that? It's the derivative of the power, as you can see here, times same exponential function b to the power f of x. I should write f of x here. Then we multiply by natural log of the base. The base is b. Now let's apply it here. What is derivative of f of x equals e to the x? Derivative of this is, derivative of the power is 1. Here we apply this rule. Derivative of the power is 1, I mean derivative of the x, times same exponential function. So the derivative is e to the x. So the function f of x e to the x has the same, its derivative is the same function. We don't change anything. It's e to the x. What about this function? This is exponential. What is derivative of this? Derivative of the power. This is f of x or g of x or the power 2 minus x squared. Derivative of that is negative 2x times same exponential function. Okay. And here we have similar thing, but we need to apply the quotient rule here because we have numerator denominator. So let's apply the quotient rule. The denominator times derivative of the numerator, it's 2. Derivative 2x minus 1 is just 2, minus the numerator times derivative of the denominator. What is the derivative of e to the 2x? Derivative of the power is 2 times same exponential function. So we write 2 e to 2x over the denominator squared. And then we write 2 times e to the 2x minus 2x times 2e to the 2x, that's 4x e to the 2x. Now minus times minus plus times 2 e to the 2x, and we have 2 times e to the 2x, that gives 4 e to the 2x, all divided by the denominator squared. How to square e to the 2x? So e to the 2x squared is e to the 2x times e to the 2x. So we add them, we get e to the 4x. We add the powers, we get e to the 4x. And if you want to simplify, you can do that. You can split from here and divide this by e to the 4x, divide this by e to the 4x, or we can leave it in this form. This is not written in the simplest form, but this is for purposes of finding the derivative. Now let's find derivative of this. This is b to the x. And we know that derivative of b to the x is given by this formula. Now the derivative here is that if we have b to the x, then derivative of, we start with b to the x, derivative of the power. The derivative of the power here is x. What is derivative of x is 1 times same exponential function 7 to the power x times natural log of the base. The base is 7. So we just write it 7 to the x times natural log of 7. Now what about e? Here we have the quotient. Here we can apply the quotient rule if you want to find the derivative of the function f. So the denominator times derivative of the numerator. What is derivative of the numerator? Numerator is 3e to the x. Derivative of 3e to the x is the same because this is a constant, and derivative of e to the x we already computed here, and we got same function. Minus the numerator times derivative of the denominator. What is derivative of 1 plus natural log x? Derivative of 1 is 0. Derivative of natural log of x is 1 over x, as we described here, the first example. Derivative of natural log x is 1 over x. So we write it here, 1 over x, all divided by the denominator squared. Plus, what is derivative of 4 to the x? We already did a similar problem in D. So derivative of the power is x, derivative of x is 1 times same exponential function times natural log of the base is 4. And then you can simplify, you can distribute this, you get 3e to the x plus 3e to the x natural log x minus, here you get 3e to the x over x, all divided by 1 plus natural log x squared. You can simplify if you want. You can bring this up here, it becomes x to the negative x, or you can just leave it in this form. Now let's take an application example. So the sales of some video game company, can be modeled by the logistic curve. This function, q of t, quantities per time, equals 10,000 over 1 plus 0.5 e to the power negative 0.5 e to negative 0.4 t. Now Q of t is total number of units sold at t months after its introduction. Production. So how fast is the game selling 2 years after its introduction? So after introduction we have 2 years, and since we are dealing with months here, t is time in months, we need to convert 2 years into months. So this is 24 months. It's very important to unify the units. And then we want to know how fast. How fast means the derivative. We need to find derivative. How fast in time. So derivative with respect to time. So what is derivative? How fast is game selling? The game selling is given by this function. So we want to find the derivative of this function. The variable is t. So what is derivative of this function? The denominator times derivative of the numerator, but the numerator is constant, so derivative is 0, minus the numerator times derivative of the denominator. Now, what is derivative of the denominator? So derivative of 1 is 0, and derivative of this exponential function is the constant 0.5 times derivative, let me do it here, derivative of 0.5 e to the power negative 0.4 t is, this is constant, so we just wrote it here. Let me erase it from here. And then what is derivative of the exponential function? Derivative of the power is negative 0.4 t. Derivative of negative 0.4 t is just negative 0.4 times same exponential function. Okay, this is derivative of the denominator all over denominator squared. The denominator is 1 plus 0.5 e to negative 0.4 t all squared. Now this is 0, and we get negative 10,000 times 0.5 times negative 0.4 here times the exponential function all over 1 plus 0.5 e to negative 0.4 t all squared. But we want to find this derivative after 24 months. So we just plug 24 for t. And then using the calculator, we find the answer. The final answer is 0.135. Can be approximated as 0.135. So this is just an approximation. Okay, so when we ask how fast, that means at time t equals 24, it's the growing or the how fast is the game selling 2 years or 24 months after its introduction is 0.135 quantities per month.